Bismillahirrahmanirrahim. Now we have the lab 12 of micro and embedded system, in which we have to Verilog programming and hardware implementation of full ladder, full subtractor, 4 1 multiplexer and 1 cross 4D multiplexer using quarter software and FGP hardware. So this is our lab 12, in which we have to implement these on Verilog STL. So first of all we have to know what is multiplexer. Multiplexer is the word called master information selector. A multiplexer chooses between a few simple or computerized input signal and once the choose contribute to a solitary. In simple words, when I am saying multiplexer means that there are multiple inputs. 1 cross 4 4 cross 1 multiplexer means there are 4 inputs and 1 output, and on the basis of the selection lines I am choosing which input have to go on the output. For 4 inputs there are 2 selection lines, so on the basis of these selections I am checking which input have to go on the output. You see on the diagram here I am showing you the 4 cross 1 marks. The 4 inputs are x0, x1, x2, x3, and there are 2 selection lines for the 4 inputs, which are c0 and c1. And multiplexer always have only one output. There are no more outputs in multiplexer, so only one output in multiplexer. And you see here the column table in which there are 2 selection lines and when on the output. When the selection lines are 0 0, then x0 will go on the output, and when the selection lines are 1 0 0 1, then the x1 will go on the output, and when the selection lines are 1 0, then x2 will go, and when the selection lines both are 1 1, then x3 will go on the output. So this is our mux multiplexer. After this we have the logic diagram of gate implementation of a multiplexer. So this is the multiplexer. After this we have a demultiplexer. Demultiplexer is basically opposite to multiplexer. In 1 cross 4 demultiplexer we have the 1 input and 4 outputs, and similarly based on the selection lines we are going to check the input have to go on which output. Means on the selection lines we are selecting that input have to go on that output. So this is our the basic diagram of a demultiplexer, in which you see that we have the only one output f input and multiple outputs 4, and ab is the selection lines. When the selections are 0 0, then our input will go on the a output, and when these selection lines are 0 1, then our input will go on the 1 output, means b output, and when the selection lines are 1 0, then input will go on the c output, and when the selection lines are 1 1, then the input will go on the d output. So this is the demultiplexer, and you can see the difference between the multiplexer and demultiplexer. Now our lab task is to implement the multiplexer and demultiplexer in Verilog STL. So here you see that I have written the code of multiplexer using gate level implementation. In the module I have written all the inputs and outputs and section lines, and the by output I have declaring my output, and input I am declaring the 4 inputs and 2 selection lines, because selection lines are also input because I am giving the command to selection lines. And then I am declaring the wire, and then I have declared the not gates. Not gates first I am declaring the output and then the input, means not first output of that gate and then the input that is going in that gate. And similarly not for the control 2 input, and then the AND input, AND gates, 4 AND gates I am declaring, and these are W X Y Z are the outputs of these AND gates, and these gates are 3 AND gates, and so these have the 3 inputs: input 1, not control 1, and not control 2, and then second AND gate as in output 1, output X, and 3 inputs: input 2, not control 1, and control 2. And finally we have the OR gate, which have the output out, and the inputs of this OR gate are W X Y and Z. So basis on the selection lines I am selecting that my input is to go on that output. When the selections are 0 0, then our input will go on, then input 0 will go on the output, and when the selections are 0 1, then input 2 will go on the output, and similarly so on for other inputs. So this is our task 1 of multiplexer. After this we have another task, which is these are the output waveforms. you see that when our selection lines are 0 0, then our input 1 is go on the output, and when the selections are 1 0, then our input 3 is go on the output, and when the selections are 0 1, then input 2 is going to on the output, and when the selections are 1 1, then input 4 is going on the output. So this is the multiplexer. Now our next task is the implementation of Dmax in Verilog STL. So here you see that I have write the code for the demultiplexer. Demultiplexer is basically opposite to multiplexer, so we have only one output and four inputs in the multiplexer. Similarly, two section lines. Here on the output you see that I have declared four outputs, y0, y1, y2, y3, and inputs is only one and two selection lines. Similarly, wire and NOT gates, I also made the demultiplexer using the gate level implementation. So here I have used the two NOT gates for the control 1 input and one for the control 2, and the outputs are not control 1 and not control 2. And similarly for AND gates, the outputs of these AND gates are y0, y1, y2, and y3, and then I am declaring the three inputs for these AND gates. One for the first AND gate, the inputs are in, not control 1, not control 2, and for the second AND gate, the inputs are input, not control 1 and control 2, and similarly for other AND gates. And finally we have the AND gates. Then after this you can see the output waveforms of these. Here you see that I have when the controls are 0 0, then our input is going then on the y0, and when the control lines are 1 0, then our input is going to the y2 output, and when the control are 0 1, then our input is going to the y1 output, and similarly when the controls are 1 1, then our input is going to the y3 output. So on the basis on the selections of controls, I am sending my input to specific output. After this we have the full adder. Full adder is here you see the truth table of full adder, in which we have the inputs a, b, carry in, and the output is sum and carry output. When all the inputs are 0 0, then our sorry, when all the inputs are 0 0, then sum is 0 and carry is also 0. When the inputs a, b is 0 but carry in is 1, then sum is 1 and carry output is 0. And similarly when b is 1 and all the inputs are 0, then sum is 1 and carry is 0. And when all the inputs are 1 1 1, then sum is also 1 and carry out will be also 1. Now you see that here I have write the code for the full adder. Here you see that I have module adder out, and all the inputs and outputs are declared here. Then we have the input carry in single bit, that's why I am declaring it separate, and then our input is a and our input is b, which are 8-bit inputs. And finally we have the output sum, which is also 8-bit, and output carry out, which is single bit, that's why I am declaring it separately. And after that we have the temporary wire, and assign temporary equals to a plus b plus carry in. So this is basically 7-bit with carry in and carry out, and all the sum is, then this will become the 9-bit, and in which our first 8 bits represent the sum, and the last bit, which is 9th bit, which represents the carry out. That's why here I am assign the sum, which is equals to first 8 bits of temporary variable and carry out, which is basically the 9th bit of temporary. That's why I am assigning these sum and carry out. So basically these are, and after this we have the RTL views of these our task. So basically these are the tasks of our lab 12, and our lab 12 of micro embedded systems is completed. And I will also add the hardware videos that I have implemented in the lab. Thank you.
ओके हमने एफ पी जी को परफॉर्म किया बाय यूजिंग वेरीलॉग, और इसमें देखा जाए तो हमारे पास एक टेबल दिया हुआ है, उसके अकॉर्डिंग हम इसकी वैल्यू सेट कर देते हैं 0 बिट, 1/सेकंड, ठीक है। इसके अगेंस्ट ये लाइट्स वगैरह ऑन हो जाएंगी जब भी हमारे पास कोई पर्टिकुलर इनपुट आएगा। सबसे पहले हम 0 0 1 कर रहे हैं, तो इसमें क्या होगा, सम हमारे पास 1 हो गया। ये बेसिकली सम है और साथ अलग कैरी होगा। जब हमारे पास ये 1 होगा फिर भी हमारे पास 1 आएगा, और अगर हमारे पास तीनों जो हैं वो 1 हो जाते हैं तो हमारे पास कैरी भी जनरेट हो जाएगा। तो ये था हमारे पास टास्क।
ये हमने फुल सब्ट्रैक्टर बनाए हैं FPGA बोर्ड पे, जिसमें हमारे पास ये फर्स्ट इनपुट है, ये सेकंड इनपुट है एंड ये थर्ड इनपुट है। और जो LEDs हैं वो उसमें हमारे पास LED 1 जो है वो हमारी फर्स्ट आउटपुट है, LED 2 जो है वो हमारी सेकंड आउटपुट है। और ये हमारे पास फुल सब्ट्रैक्टर का जो टेबल है, तो इसमें देख रहे हैं हमारे पास जब सारी इनपुट जीरो जो हैं तो हमारी LEDs वो ऑफ हैं, तो हमारे पास आउटपुट भी क्या है 0 0। जब हमने इस इनपुट को 1 दिया तो हमारी दोनों इनपुट्स 1 1 होगी, जो कि हमारे ट्रुथ टेबल से हो रहा है। उसके बाद हमने इसको दिया, फिर इसे 1 किया तो हमारी फिर आउटपुट्स क्या होगी 1 1 होगी। उसके बाद फिर हमने जब फर्स्ट और सेकंड इनपुट को दोनों 1 1 किया तो हमारी आउटपुट्स क्या होगी 0, क्योंकि 1 1 0 हो गया तो फुल सब्ट्रैक्टर हो गया। फिर उसके बाद हमने जब इस थर्ड इनपुट को भी 1 किया तो हमारे पास बारो इनपुट 1 हुआ, तो फिर डिफरेंस एंड बारो आउटपुट जो दोनों हैं वो 1 1 हो गए। तो ये हमारा जो FPGA बोर्ड था वो कम्प्लीट हो गया।
ये हमारी मक्स की कॉन्फ़िगरेशन है, जिसमें पहली दो जो है वो हमारी सिलेक्शन लाइन है। तो अब जब दोनों सिलेक्शन लाइन ऑफ हैं तो जो फर्स्ट इनपुट हम ऑन करेंगे तो वो आउटपुट पे जो है वो डिस्प्ले हो जाएगी। हमने एक ऑन की और हम जो है वो जब ये ऑन करेंगे, जब जो हमारी थर्ड इनपुट है बेसिकली आउटपुट पे पोर्ट्रे हो जाएगी। उसके बाद हम ये करेंगे तो ये आउटपुट पे पोर्ट्रे हो जाएगी। और जब हम दोनों ऑन करके आखिरी जो है वो ऑन जब हो जाएगी तो आउटपुट पे हमारी डिस्प्ले हो जाएगा। तो ये हमारा Dmax का जो सर्किट है, इसमें पहली दो जो हैं वो सिलेक्शन लाइंस हैं S0 और S1, और ये हमारी इनपुट है। तो पहले में हम जब चेक करते हैं कि जब दोनों सिलेक्शन लाइन 0 हैं तो हम इनपुट ऑन करते हैं, जो पहली है वो ऑन होगी। फिर हम सेकंड ऑन करते हैं, सेकंड ऑन हो गई। फिर हम थर्ड ऑन करते हैं, थर्ड ऑन हो गई। और हम जब दोनों ऑन करते हैं फिर लास्ट वाली ऑन हो गई। तो ये हमारा जो है वो Dmax का सर्किट है।